Ladies and gentlemen, welcome back to my bench. Today we're going to be looking at this, basically, Crown XLS 602 amp. Today we're going to be looking at this, basically, Crown XLS 602 amp, or 602, depends what type of person you are. A mate of mine gave this to me and he said, well, you know, you can use it. So I was like super excited. It's about a 400 watt amplifier, you know, stereo amplifier. So I was super excited, but he said there's one catch. I can use it as long as I fix the thing. So yeah, it's not working. We're going to open it up, see what the problem is, and see if we can get it running again. We were switching it on and it would trip electricity just immediately. You'd kind of put the little switch on, you'd see some smoke coming out the back right corner here, and yeah, electricity just trips every time. So I know what to expect because I've already opened it up. It comes standard with a wiring diagram. Not quite. I pulled this off the internet. I think I got it from Crown's website. And the smoke came out of this little thermistor. Just a little kind of protection device, I suppose. It's on the power section of the board over there. For those of you who have seen inside amplifiers, you're going to see that there's quite a big part missing here. Well, that is the transformer. It's got a toroidal transformer. Quite a big thing, heavy thing, and I've done a little bit of testing. You can see it's the XLS 602D. That's the model that it comes from. Oh, come on, there we go. It's a 74074 and a 18.30 18.3. This is pretty much the culprit. I've seen another two amplifiers. It's actually two little active subwoofers, and nothing was wrong with the amplifier section, but the transformer, now they had smaller transformers, but the same thing happened. The same problem I saw on the power board. Eventually opened it up, spent a couple of days looking at it, and I ended up having to rewind the transformer. Well, I'll unwind it first, and then found that the primary winding was burnt out. So I just took one or two little windings off, connected the burnt pieces again, a bit of a botch fix, off the cuff type of thing. And those have actually been running fine. Both of them have been running fine for probably about 6 months now. And I use them, I run them hard. So I'm hoping that is going to be the case with this one. The circuit diagram is not going to be too important to us right now, unless there's other stuff that's wrong with the amp. So we'll just get rid of that. And I've got a replacement for this little thermistor. Short of buying a new one. Now, I did try and buy a new one. I spoke to the agents for Crown in South Africa, and they said it's quite an old amp and they don't have any stock. So the next best thing that I wanted to do was to phone a couple of the transformer winding places.
We're sorry, the number you have dialed is not in service at this time.
Now there's a couple of those around town and around South Africa, but none of them actually wanted to wind me a one-off transformer. They all want, say, an order of 10 transformers, and that's just not feasible. So, I think, as I said, what I'm going to do is, somebody's at the gate. Okay, so we're going to unwind this transformer. It takes a heck of a long time. Now, those other little ones, they were about this big each. They were, I think they were about 150, 160 VA. Much smaller windings, and that took me about a day to completely unwind and fix the problem and then rewind them. What I did with the last transformer, I don't have this, I think it's like a heat shrink type of tape installation type of thing. I unwound it quite neatly and then reused it again. I actually just wound the transformer up and then put a bit of hot air around it from using a heat gun, and it shrunk down nicely back onto the transformer. So that's what I think I'm going to do with this one. Hopefully it works. It worked pretty well last time. Next thing to do is just to get this green tape off as well as I can. So something that's quite important before we take this apart is just to make sure that when I disconnect these wires, all these colors from the actual windings, is that I get them back onto the same wires or the same windings when I put it back together. That's quite important, so that I can get the same output voltages from the transformer. These are the main side, the 220 volt side that comes in. Those will be joined inside. It'll be joined underneath both of the secondary windings. All of these little pieces of plastic that come off, I'm just going to make a note of where they go, and we're going to put them back exactly the same way they came off. I've realized that my little idea of leaving the red, the yellow and the black little insulators on the wires, that's to try and identify them when I put it back together, that's not really going to work, because one of the windings goes over and then one of them goes down, and these two are joined together, so I actually have to split them. So what I'm going to do, the ones that are joined, they've got these little sheaths over them, and then it's just soldered together. So I'm just going to pull that little sheath off, and then I reckon for each one of them I'm going to cut them differently. So there's the two ends right over there, and I'm going to cut these two off at kind of an angle, maybe a 45 and a 45. These two I'll leave squared off, and then these two I might just put a little bend in each one, so that when I wind the thing back together, I know that these the two matching ends must be soldered together. Although what I should do is I probably should also write down that the sort of the pointy end goes onto the yellow, or the flat end goes onto the black, and the hooked end also goes onto a yellow. I think that's a good idea. Now comes the tough, well, not tough part, but just really the boring part, is to unwind this wire, or the secondary winding. Now I don't have a machine to do this. Those are, I know you can, I think you can make them. I don't think you can make them to unwind transformers. I've seen homemade ones to wind transformers, but a nice good old trick is to just use something like this. This was a piece of 20mm conduit, and I just heated it up, just made it soft, squashed it in between two planks to make it flat, and then cut out two little V's on each end. So what we're going to do is we're going to wrap the wire around, and we'll stick it through and unwind it, and as it unwinds, then we'll wind it around this thing. So tying this with tape just helps a little bit to make sure that the wire stays nice and tight. That's as we start rolling. Well, of course after a couple of rolls it'll just kind of tie into itself, but what we're going to do is we're going to kind of do that, and we're going to not bend it too sharply, but we're going to give it a nice little, keep it tight basically, and we're going to take this now and we're going to feed it through, and as the transformer unwinds, so we're going to wind it up around this piece of plastic. This is quite a lengthy process. I really need to tell you guys that, for anybody that is thinking of unwinding and rewinding their own transformer, but it is quite rewarding when you spend a lot of time doing something and it actually works once you've repaired it. Of course, if it doesn't work, you've just wasted a whole lot of time, but it shouldn't be a total waste, because hopefully we all learn from our mistakes and we are able to not make the same mistakes the following time. Gee, this thing's getting a little bit hooked up here. Okay, let's hope this doesn't get too messy. I noticed last time when I unwound using this technique, it's quite important to unwound the conductor and not then wind it up again, or make it turn around itself. So you unwind it without actually turning the copper. That just makes for an easier wind the next time, and then you can generally get it back into the same sort of shape that it was in before. It tends to wrap up a little bit better. The first one of the last two that I did, on the first try that that I unwound and rewound. It worked fine. It was no problem. It's just that the wind was a little bit fatter than what it should have been. But when I did it the second time on the second transformer, I got it back to pretty much standard. So I was able to wind the windings almost as tight as it was originally, which is nice. I don't think it really affected the performance. I might have lost one, maybe two windings, so that's not really going to affect it very much. Okay, there we go. Looks like we've just reached the end. The first winding that came off, I'm just going to mark that as number 1, and then the second one that I took off, I'm going to mark that as number 2. So when I wind them back on, and this will be number 3, I'll start with number 3, wind that one on, then wind number 2 on, then wind number 1 on, so that we get them both in the same order, so that the chances of success are as high as possible. What I am going to need to do is, I only made 2 of these, but luckily I've got a third. Here we go. It's a third one that I flattened, so I've just got to cut out the 2 V sections, and it does fit through the middle. So let me go and do that. I'll be right back. I hope it's like the other 2 that I repaired. On those other 2, I was lucky enough to unwind the insulation on the primary, or between the primary and secondary windings, and I could see the problem straight away. There were 2 or 3 wires that had kind of burnt off. I think what had happened is the insulation, the enamel insulation on the wiring had failed. It looked like it was on the turns, on the bends, and it obviously got quite a bit. It got hot and started arcing maybe through there, and then just burnt or shorted out completely. Funny thing though, the thermal fuse didn't blow. It's normally got a thermal fuse wound into the middle of the transformer. That's on the primary side. So both of those were fine. So it obviously didn't get hot enough to pop that little fuse. Of course, once that fuse has been activated, or it's done what it needs to do, then that's pretty much it. You have to put in a new fuse, or just short it out, which is not the safe thing to do, but in a pickle it will work. But rather, if you can, get a replacement fuse. Just reached the end of the last winding, or the last secondary winding. It wasn't too bad. Nothing smells burnt so far, so that is, well, it's a good sign, but also a bad sign, because if something smelled burnt, then we would know straight away that that is the problem. But I suppose we'll have to wait and see. Basically the same process as last time. Just going to try and save the insulation. We'll unwind it as neat. Well, no, we don't really have to unwind it neatly, but without breaking it. So I can reapply it at a later stage. This is the bare primary winding. Also pretty thick copper windings, which is quite nice. I see here's the burnt section. So I'm hoping it's just a couple of wires that are that have, well, they're not broken, but possibly the insulation has come off of them, and hopefully they are close enough to the edge so we can just unwind them and just re-insulate them, and then we'll wind them back on. But for now we've got to actually get to them, and the main wires, they are quite well protected. They are under this sort of layer of plastic. Well, they're between a layer of plastic. There's one layer on the actual windings themselves, then these 2 joiners come in, and then it's got this protective layer over the top of it. Okay, so there were actually 2 layers of plastic underneath the connectors, and which makes sense. I mean, you want a very good insulative layer between the actual windings and the joints, and then there was just a single layer on top. You can actually see how the wiring is burnt, and it's actually burnt the insulation. Phew! It's actually not great at all. So there's the damage. You can see there's actually two conductors that are completely burnt off, and the two next to it on the left and the right, they are also damaged. It just looks like the insulation is damaged, but these two, well, where are they? There we go. Framing, come on. Those two are completely burnt off. Now, I don't know what would have caused this type of failure. I'm guessing possibly a weakness in the insulation. Maybe it is part of the manufacturing process, and it starts getting hot over time, or there was maybe micro fractures in the actual copper itself. So yeah, over time it probably gets hot and then becomes a weak spot, and then it eventually burns out. So this is basically 3 out of 3 transformers that have done the same thing, the exact same thing. On the outer winding they have burnt out, also taking out two or three of the windings. I managed to clean up a lot of the mess that the short circuit made. I cleaned off a little bit of the carbon and the black plastic, or the plastic that had melted and gone black. Cleaned that all off, and there's a couple of conductors. Hang on, focus, there we go. A couple of the conductors were slightly damaged, the coating on them, so I've ended up putting some more enamel coating. I'm just waiting for it to dry, just using the tape just to insulate it from everything else. So yeah, putting a little bit of coating onto each of the damaged conductors, and then I'll solder the two ends. These, I can't really see it there, but those two ends, I'll solder them back together. That is the two ends that burnt off, and then we'll rewrap the transformer and take it from there. For any of you that are thinking of repairing transformers like this, it is quite a lengthy process, very finicky work. So what I've ended up also having to do is to create a bit of a gap. As you can see, there's the metal, or the metal ring underneath here. I don't know what the technical term is for that ring, but what I've done is I've basically taken each of these little copper windings, and I've pushed them a little bit to the side, to the one side and to the other side, just to create a nice gap. So I'm able to clean inside where the plastic was burnt off, and then it also allows me space to clean each of the wires or the conductors that kind of run along the section where it is burnt. There was a lot of I don't know what you would call it, like smoke damage for lack of a better word. So I've had to clean that off. I've just used a bit of good old benzene and a little earbud. So there we go, you can actually see the earbud is pretty dirty. Cleaned that all off, and yeah, this space that I've made over here, it actually helps the process a little bit. It makes it a lot easier to see what's going on, and then also to make sure that you get it right, because this is pretty much a one-time thing. So unless you like doing things over and over, spend a little bit of extra time, get it right, because once this coil and or the primary side of the coil is wrapped up, and you've put both secondary windings back on, yeah, I would say anybody is pretty much going to lose interest if it doesn't work then. So take the time, do it properly, and the results should pay for themselves. I'm not sure if it is the correct thing to be using. Just thinking about the fact that masking tape is basically paper with adhesive on it. So over time the paper is probably going to dry out because of the transformer getting warm, and the adhesive is going to sort of go a runny type of sticky. So not too sure how well it's going to work in the long run, but I mean, I reckon if you spend a couple of hours fixing one of these things and you get maybe another year's service out of the product that you're fixing, well, it's worth it. Otherwise, if anybody else knows of any other things to use, I did think about using insulation tape. Got some over here. I really like this Nitto brand. Not sure, I haven't actually looked up who makes it, but it works really nicely. Although, as much as I like it, I don't really like it for winding up this type of thing, because the adhesive on these insulation tapes, when they get warm, they get really sticky, and the sort of the adhesion tends to let go. So I found it to be more sticky, well, for the adhesion to stay for a lot longer when there's heat involved, using masking tape. So yeah, but otherwise, if you guys know of any other different tapes that I should be using, maybe for some future repairs, let me know. Always keen to see what other people think, or hear what other people think. I'm by no means an expert at at what I'm doing or what I'm trying to achieve. Yeah, I just thought I'd give it a try, and we'll see what comes out the wash in the end. I've ended up connecting both of the wires again by twisting them together and just soldering them. So the one coil comes around from the top and the other one comes around from the bottom, and then it just bends over and then it joins. So that shouldn't be a problem. I've also covered the bend and the join with I think this is like a woven fiberglass like sheath. So those are over all the joints and the bends, and that should keep them nicely insulated. And the pieces of wire that I cut out were these two pieces. So we probably lost about maybe 1.5 turns on the primary, so that's not too bad. I would have liked to have joined them so that I didn't lose any turns, but you know, had to do what I could with what was left of the actual wire itself. So yeah, it'll be interesting to see how this actually affects the performance of the transformer, and especially once I've rewound the two secondaries on. Hopefully I can still get the same number of turns back on with the secondary windings. I've now got to the point of rewrapping the transformer, putting that insulation over the primary winding. Guys, it takes a long time. So sit down in front of the TV, do something, but it took me about, I would say, almost 3 hours to wrap this up. So yeah, it does definitely take a long time, and I did test along the way. Now there is 2 wrappings on here, so I put the first piece on, used a little heat gun there, and kind of heated the whole wrapping up, and then it kind of shrinks over the winding. Tested it just to make sure that as the wrapping was shrinking, that it didn't cause any more problem inside the transformer. It didn't, so all was good. Then I wrapped the second bit of insulation on, and I'm about to test it now. And what I thought of doing is also just showing you the actual bulb itself. So instead of the bulb being kind of over there at the plug, just to prove that I'm not talking bullshit, this does work. So again, you know, don't be stupid, don't do this at home. Do as I say, not as I do. I've got my mother on speed dial, I've got my safety, my glasses on, and we're going to plug it in. Before I plug this in, just remember one thing, that this is live electricity. It will kill you. It doesn't take any prisoners, so be very careful. If you're not comfortable doing this, you know, go play outside. To prove that we do have electricity here and that the light bulb does work, what I'm going to do is I'm going to close the circuit. Well, she's not looking too good there. I'm going to close the circuit, bam, and the light bulb comes on. So there is 220 volts coming out of here. So what we're going to do is connect up our load, or our primary transformer, and all going well, hopefully nothing has gone wrong while I've wrapped this. We're going to connect it up and the light bulb should not come on. So let's have a look. There we go, all connected, and transformer is not heating up at all, which is good. And the most important thing, the light isn't coming on. So if something was wrong or went wrong while I was wrapping this, then the light bulb, it would shine. So we are all good to go for the next part of the repair process. I'm going to unplug this now. This is not good. This is not good. I really should make some type of test bench or something. Maybe solder maybe solder these wires onto there with some crocodile leads for future use. But you know, shits and giggles. I don't know. Next time maybe. don't make the mistake I did last time, thinking that you are working neatly and it is going to work, because for the last transformer like this that I did repair, I ended up wrapping the entire transformer, re-wrapping the primary winding, the secondary windings, and school bore area. Didn't test it while I was putting it together, so ended up wrapping this whole thing. It took me like a day, man. And then I tested it afterwards. I thought I was better than what I actually was, and it didn't work. So what I did is I unwrapped the whole thing a second time. That is absolute cuck. Don't let that happen to you. Just take a few minutes, test at each step, just to make sure that nothing's going wrong. So that'll save you a whole lot of time, and cheers maybe. Something to remember when you are rewrapping. You can see I haven't flattened out all of the wire, so what I'm going to do is I'm going to try and start off the wrap in the appropriate spot, so that we can try and get these corners in the wire to coincide with the corners on the actual transformer, so that we try and get it back into the same shape that it was in. That's going to kind of ensure that the wrap is nice and tight, as close as possible to what it was. And then that way hopefully we don't lose too many windings. So we don't, I mean, if we're going to lose 10 windings, that's actually very bad. If we lose one winding, I don't think it's going to make too much of a difference, but we'll try our best. Take your time and do it properly the first time. Transformer has finally been rewound, all of the secondary windings. Man, did it take a long time, and my hands are broken. It is far easier on the hands winding a transformer, the smaller ones, because the copper conductors are much smaller. So it's you know, maybe something like that, even a bit smaller. This thick stuff, geez man, it's, yeah, I wish I had a winding machine. Maybe that's a project for another day. But what we're going to do now is we're going to plug it in. I haven't plugged this in yet, so we're going to use our light bulb to check if it's going to work. And that's just for a bit of safety. Got the safety squints on, mum on speed dial, and let's see what happens. If I can get the plug in. There we go. Okay, so there's our bulb. That's just to limit the current that we are looking at, or not looking at, but that could potentially travel through our transformer. It is quite a large transformer. Need to get some little bits and pieces on. Again, don't try this at home, it's quite dangerous. Got the multimeter set onto AC. We're supposed to get 74 volts from the two reds, or between the red and the black. Hopefully the repair has been successful enough to get voltages close to that. Well, that's if we get that far. So just to check, to show you that there is actually live electricity, if we touch that, we've got our light bulb that comes on. So what we're looking for is the bulb not to come on. 3, 2, 1. 3, 2, 1. Contact. And our voltage is slowly climbing. We're at 70, call it 72 volts. So not too bad, not too far off the mark. We did lose probably one winding. There's a bit of the wire that I had to cut off, and maybe we lost another 1 or 2 windings with the way it was rewound. I mean, obviously it's not as neat as what a machine can do it. So at least one of the reds is working. I'm just going to disconnect here again. Let's check the second red. Yes, we should get a very similar voltage now. Okay, contact. Yeah, and I would say that's pretty good, 71.5 volts. So I think we'll be able to operate on that. Well, let's hope. We'll plug it in and see what happens. Light bulb is still off, which is good. These yellow windings should give us 13.8 volts. Well, that's according to the spec plate that was on the transformer. Okay, so we are slightly over voltage. There's 17 volts, not too bad. And the final and last winding. Contact. And there we go, 17 volts again. So far it's looking good. Got the amplifier here, and I've actually decided to just give the transformer a little bit of a test before we actually do the final wrap. So while I put it in, something to keep in mind, that when you are testing things like transformers, you know, things can go wrong. So make sure they are properly insulated and not touching any of the chassis or anything like that. You know, any other maybe wires that might be sticking out. You definitely don't want to fry the rest of the board if you, especially if you've spent a lot of time fixing something like this. So be sure of that. I've also got our little test light here. We're going to plug in the amp through this test light, just to limit any damage that might happen. Can't really remember how these wires or where they all connect to. I'm just taking a bit of a guess here, but pretty sure this is correct. I mean, it was a couple of months ago that I took this apart, and I didn't actually take a photo or write down what goes where. But I think we should be able to get away with a fairly good guess. I've got the transformer lying on 2 rubber mats. Those were the original mats that it lay on or was wedged in between, so that should be good. Definitely not touching any metal anywhere. Also got my safety glasses on just in case something shoots out the top here. So let's plug it in, see what happens. Maybe the electricity trips. I'm not too sure. So again, what we're expecting to see is that light to come on, and the amp's going to run through its basic its check, or its fault check, and then once it can see that there's no DC going to, say, the outputs, or there's no over voltages or anything like that, the 2 little relays will switch on, the fault lights will switch off, and then it's good to go. Where are we going to let the smoke out now? 3, 2, 1. Woohoo! Start it up. Yeah, that's good. So we actually saw the light. It was dim. It came on dim, and then as the amp kind of went through its test and switched on, both output relays switched on, and the light went off. So that's a result. I'm pretty happy about that. We haven't tested it under load yet, of course, but on the face of it, everything is looking good. Yeah. Result. I'm going to take this transformer out of here again, wrap it up, and just heat shrink it again, so to make it as neat as possible. We're going to put it back in its mounting plate here, that mounts on top, and once that's done, we'll plug it in. We'll put some sound input into it, connect some speakers up, and then we'll give it a proper test. I've got the transformer wrapped up again. It only had 1 layer of insulation. It took about probably an hour to just wrap it up neatly again, and use the heat gun once again to just shrink the coating, or shrink the insulation nice and tightly over the coils. Yeah, I would say it came out pretty neatly. Of course, these two are the mains leads are still in the same place, but the secondary output leads have changed slightly. They are a little bit more spread out, but that's just kind of how the ends of the conductors ended up. It's not going to make any difference to the performance of the transformer. So yeah, overall pretty happy. And for those of you who say it can't be done, bullshit. Anything can be fixed within the right amount of time and the right amount of effort. Thanks for watching. Check you later. Cheers.